Right now, you probably feel like you're sitting completely still, but at this exact moment, you are actually hurtling through space at roughly 1,670 kilometers per hour if you're near the equator. That dizzying momentum is a leftover feature from the very birth of the solar system. About 4.6 billion years ago, violent collisions of swirling gas and dust generated immense forces that set our planet rotating. So why hasn't it slowed down? Think of a figure skater pulling their arms in to spin faster and faster. Because Earth is floating in the frictionless vacuum of space, there is almost zero opposing force to drag on it. We keep rotating effortlessly. That uninterrupted spin provides our reliable cycle of day and night, and it will keep doing so for billions of years. All of our weather patterns, our oceans, and our daily lives are built on top of that relentless, invisible momentum. A sudden interruption to that spin would be catastrophic. The only reason your coffee isn't flying across the room right now is that you, the oceans, and the atmosphere are all locked in a perfectly synchronized system, traveling at the exact same velocity. But imagine the solid Earth suddenly hits a theoretical cosmic brick wall. The crust halts completely, and the planet stops spinning for exactly 5 seconds. You might have heard that if the Earth stopped, you would instantly be flung into the vacuum of outer space. The math actually says otherwise. This chart illustrates escape velocity. To break Earth's gravitational pull and enter outer space, you need to hit roughly 40,000 kilometers per hour. Even at the equator, our atmospheric inertia is only 1,670 kilometers per hour. We fall drastically short of this towering bar. You wouldn't float away. You would remain trapped right here on the surface. And being stuck on the ground when the planet stops but the atmosphere keeps moving is a much more violent fate. In the very first second of the halt, the solid ground beneath your feet stops on a dime, but the air does not. The atmosphere carries its momentum forward at a staggering 1,670 kilometers per hour. Supersonic winds of that magnitude would instantly tear steel-reinforced buildings off their foundations. The sheer friction would be strong enough to obliterate the top layer of the Earth's crust, scouring away fields, forests, and pavement. How fast those winds hit you depends entirely on your latitude. The Earth is thickest at its middle, meaning the rotational speed is highest there and tapers off as you move north or south. Looking at this globe, you can see the wind velocity vectors shrinking as they move away from the equator. In places like France or New Zealand, the winds drop to around 1,180 kilometers per hour. That is still much stronger than any storm recorded in human history, and completely unsurvivable. By second 2, the very air we rely on to breathe weaponizes its own inertia to strip the surface of the planet bare. Yet the wind isn't the only hazard. The moment the Earth stops, a secondary disaster triggers because our planet isn't exactly round. As this diagram shows, constant rotation generates a powerful centrifugal force. This force pushes the Earth's mass outward at the equator, creating what physicists call an equatorial bulge. When you pull the emergency brake, that centrifugal force instantly vanishes. Without the spin pushing the mass outward, the Earth rapidly flattens into a mathematically perfect sphere. For the world's oceans, this is catastrophic. With the bulge gone, all the water gathered near the equator has nothing holding it there. The oceans immediately rush away from the equator, flowing rapidly toward the north and south poles. Over the final 3 seconds of the halt, this massive, sudden water migration generates a global, unstoppable mega tsunami. The sudden loss of planetary rotation instantly turns Earth's own gravitational and fluid systems against us, reshaping the world map in a matter of seconds. Finally, the 5 seconds are up. The solid Earth instantly resumes its breakneck 1,670 km per hour rotation. But the sudden restart creates an extreme physical whiplash. The billions of gallons of water that just gathered at the poles are suddenly thrown into reverse. A colossal, backtracking wall of ocean water slams into the continents a second time. This massive wave crushes whatever the supersonic winds left behind. The true devastation of this scenario comes from the brutal, unavoidable whiplash of the restart. Once the waters recede, the surface is unrecognizable. Every building, all farmland, and our entire technological infrastructure are wiped out. The only geographical safe zones on the entire planet would be standing exactly at the north or south poles. At the extreme top and bottom of the Earth, rotational velocity is at its absolute minimum. The atmospheric winds there would be the mildest, giving you a slim chance at weathering the 5-second storm. For the rest of the global population, the only theoretical survival option would be a heavily reinforced subterranean bunker, buried deep beneath the cracked ground. Luckily, Earth's momentum won't fail us anytime soon. In fact, the sun will expand into a red giant and swallow the planet billions of years before the Earth ever stops spinning. Until then, those silent, invisible mechanics keep turning, safely maintaining the world exactly as we know it.